Given a string S consisting of small English letters, find and return the first instance of a non-repeating character in it. If there is no such character, return underscore. So as an example, we have for S is equal to A B C A B A C A B A D, the output should be solution C. And that is because there are two non-repeating characters in the string C, D, and we return C since it appears in the first string. Okay. So let me go back and look at it again. So they have A, B, A, C, A, B, A, and D. Okay. So the way they did it is they just kind of have like a few characters that are repeated. So as an example, we have A twice, actually three times. We have the B that appears twice. The B is here, B, and then A is here. And we have the C, which is only appearing once. So C and D only appear once, but the first occurrence of the character that only occurs once is C. So that's a non-repeating character. So our objective here is basically to find the first character that is non-repeating and return that as an output. Now, how could we actually get to that? And as a second example, let's read the second example. They have like A, B, C, A, B, C, A, B, 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 all of that stuff. And then it says that the output should be underscore, since there is no characters. Since there are no characters in the string that do not repeat. And just the whole thing. At first glance, I'm thinking about just moving through the string. If we could just move through the string and store those values in some data structure, and as we move through it, then we can just kind of have like something that's gonna increase the number of occurrences in that specific data structure. I'm thinking about a hash map in my mind. So that's the first thing that comes to mind, just using a hash map to just kind of store these and just increase the number of occurrences. And as we actually move through it and we increase it, I want to just keep track of who has the least amount of like occurrences, and we want to keep track of who has the least amount of occurrences. And the way we could do that is, I'm thinking first, when we kind of like run that for loop and we just put the numbers in there. Because I'm thinking like that might be an issue, because I was thinking about just like going through the entire string. As we move through it, as an example, we could just kind of like do something like this. Let me show you what that could look like. So as an example, we can have like two things here. The first thing is going to be the example, which is this. I'm doing this so we can have an idea of what we want as an output, and how we could think about a solution that would actually work here. And the first thing is we just store the first character, which is the A. And when we store the A, it's going to be A. And then when we move forward, we'll store B. and then we move forward, and we ask ourselves, like, as we store the elements, we have to ask ourselves if the data structure contains, if the hash map contains already that character. That's the whole thing behind that's the whole idea behind it. Now I'm thinking that there is like the issue with the hash map is that it's not actually storing the key value pairs in order of entry. So that's gonna present that's gonna present a complication. So let's see if there's like a hash map. I think we have like some other form of data structure which is similar to a hash map, but that is ordered. Hash map ordered. So that, yeah, there you go. That's a linked hash map. So yes, that's the linked hash map. A linked hash map is actually going to store, is going to keep the same. It's going to actually, so the linked hash map is going to keep like the order of insertion. So in this case, it says that linked hash map is precisely what you're looking for. It's exactly like a hash map, except that when you iterate over it, it presents the items in the order of insertion, in the insertion order, I should say. Now that we know that, let's just explore what it looks like. Now let's take a look at what the linked hash map looks like. So it's just the same as a hash map from what I can see so far. So yeah, you pass in the thing, you could just kind of pass in the generics, here. They're using generics, and we can just use like character char, and then an integer to kind of like increase the number of occurrences, I should say. So we increase it that way, and then the methods that they have contains value. They have a get, remove eldest entry, returns true if this map should remove its eldest entry. Okay, and we also have like entry set and contains key set. Okay, great. So yeah, I think that should work. If we use like that linked hash map, we could just kind of like start by doing, let me do something here. So if we use like a linked hash map, we could just start by having we will have like the first letter that's going to be included. So it's going to be A, and it's going to be pointing towards having just one entry, and then we move on. Let me actually remove that so we make it easier. There you go. So now when we move on, the next letter is actually B. So we'll do this, and then 1. And then we move on, and then the next letter here is A here. So we go back to the A and we increase the number of occurrences of A. Next letter is C. So C dash dash, and then 1. Let me add this right here. It looks clear better like this. And then the next letter is another A. So we go back, increase to 3, and then we move forward, and we have B. So B, keep going, and we increase B to 2, and then we have another A. So we go to 4, and then the last letter is just a D. So we'll return just so that's the equivalent mapping. Is going to be 1. And now that we have this, and we know that it's actually going to be linked in the form of like a linked list, all we have to do is just use the entry set function and just explore that hash map. And then as we loop through it, once we find something that is actually equal to 1, we just return it, because that's the first occurrence of it. And yeah, that's the way I'm thinking. And so if the number, so if the key maps to a number of occurrences less than number of occurrences equal to one, then return it immediately. Is this how we write immediately? Let me make sure. Yep, correct. Good. So that's the way we do it. And now let's start by just let's just start with the for loop. We'll have like before we start with the for loop, let's just start by having the linked hash map like this, and then we'll do char, and then the thing is, okay. Okay, let's just do string here, since string, and then we'll do int, and then here, it's actually required. They will require us to send a char as an output. So okay, so yeah, we will have to use we have to use character, not just the type char. We have to use char, not char but character. Yeah, there you go. And then here we just have to say is equal char, and we'll call it map, and then our map is going to be equal to new linked hash map like this, and then parentheses. My apologies, should be integer as an object here. Good. And for now we don't need to see the test, so we can just make this smaller, bring this back here, and yeah, now we have this ready. So start with the for loop now. For character, and we'll use it for each loop, and then we'll say map that key set like this, and that allows us to just kind of have like the keys contained in that hash map, in that linked hash map. And now when we go back, we could just say, hey, for each character, if the character is not there, so the first thing is figuring out the order. So you know what, let's just use like a regular I should say a regular for loop, not the for each. So we'll say int I, so int index, I should say index is equal to 0, and then I is less than hash map dot size that size, and then here should be index, and then we end with index plus plus. Good. So now we can go back and say that if let me just store this here. Character, current character is going to be equal to s that at index okay, so string at index Java. So let's just make sure that we are getting the correct. So they're using like char at, so it's not supposed to be index at, it's char at. So we use that char at like this, and then we pass in the index like this. There you go. So now we have the character at a specific index. All we have to ask ourselves is if the current character, so we have to ask, let me backtrack actually. We have to ask if our map that contains, so if our map contains that element, that's the question that we want to ask. But I will start with, by my logic, I want to start by if the map does not contain that character, then we want to just set the number of occurrences to 1, because that's the first time we encounter it. So if not contains key, like this, and then passing current character. So if that map does not contain the current character, then I want to actually just go in there and say, hey, map that put, and then I'm going to say, hey, map that put, and then add the character, which is going to be current char, and then I need to add the occurrence, which is going to be 1. Simple. Now that's good to go. And however, if it's already contained, what I want to do instead is not, what I want to do is just increase the number of occurrences. So we'll do map that put, and then we'll do, hey, map that get, so we can get the current number, map that get, and then we pass in the current character, because that's going to be considered as our key, current char, like this, and then increment it by 1. So we could just increase the number of occurrences since we already have it in the hash map. So that does the work for us. And at the end of this, we would have actually, inserted all of these values here. And yeah. And now, once we added everything, we go back and we ask ourselves, hey, who is present once? Hey, which character is present only once? So that's the question we're asking ourselves. So we need to just go through the linked hash map and I want to see how. So going to that linked hash map, we want to just kind of have like we can use like a for each, since we already know that it's going to be ordered. So now we could use that for each loop and just say for each. And what am I trying to return? I'm trying to return the character. So I'm going to do character char like this. So we'll copy just this thing, bring it here. Okay, and then for each current character, and then we use map that, uppercase, so map that key set. You know what? Yes, so that's the key set. So that's good. And I want to ask myself if the current character, so if map that get current character, so if the current character is equal to 1, like double equals. So if the current character, if I pass in, because that's considered the key, right? So we just pass the key, which is going to be A or B or C or D, and we'll say, hey, get that specific key and see what is the actual number that's contained in there. What's the key value pair that's associated with that specific character? And if it's equal to 1, that means that it only occurred once, right? So what do I want to do? Just return it. So return. And I want to return the current character. And that's my objective here. And of course, now the question is, what happens if we don't find any characters that are actually like repeating only once? So if we don't find it, that's why we have to go at the end of this. That's why we have to go outside of the scope of that for loop and just say, hey, return. What are we going to say? Return underscore, because we didn't find anything. And I could actually, so that's going to be considered a string. So I'm using double quotes here. So very important. So if you use single quotes, it's going to be considered as a character. If you use double quotes, then it's considered as a string. That's why I had that error. Now you see that everything is fine. And let's just recap. So from the way I was thinking, we start by having the hash map. We have a linked hash map, I should say. Not a hash map, a linked hash map. And then we use the linked hash map to store every value and count the number of occurrences for each character that appears. And once we have the list of each character in that linked hash map, we can just iterate through it and just ask ourselves if there's any characters present in that map that is equal to 1. That's what we're doing around line 23 to 25. So once we know that it only happened once, we just want to return that specific character because it only occurred once. Otherwise, we go outside of the scope and we just return underscore because we didn't find it. That's my logic. And now let's just bring this around and yeah, let's just run so we can see what happens. Okay, a few issues here. So the expected is C and I returned underscore. Cool. Now I want to know what happened because this is not what I wanted. So, and it seems like it only passed three tests. So I think that's a very bad output so far. So our percentage of success is not good. So what I want to do is kind of like debug and see what happens within, that map. I want to see which characters are actually there. So what I'm gonna do here is just simply have like a system that print line that's gonna tell me exactly which characters are there. So current character. So print it out so I can see it, even if it's even if it's not equal to 1. I want to see how much you have there. So let's run that so we can make sure that we see the numbers. So output, what happened here? So console output is empty. How is that empty? We have no errors here. So you know what? I'm gonna remove the print statement here, and I'm gonna actually add it at right here. So each time, whenever we actually go through a number, I want it to be printed, so I know which one it is. So let's run it again. It still says empty. That's strange. We have a system.out.println. I want to see the console. Why is it not printing my solutions? That's weird. Okay, something weird is happening here. I can't even see my output statements here. My print statements, I should say, here. I want to do something. Let's just print this without, like this. I want to do a quick test, and we can just make sure that it's actually printing. So now it's printing. It works. Now, I want to send it right after this and then print it and see if that works. See, that's strange. Okay. I was thinking maybe like the character, the type character might create an issue, but I don't think, since we have like a chart here in the store in that, type character, that should have actually warned us if there was an issue. I don't think that's an issue, but now something is off because the print in that for loop is not being printed. So why is it not printed? My print statements are not printed. Index equal to 0. Index less than map that size. Index plus plus. Then we go back. We have a for loop and we have a map that key set. That's strange. Let me think a little bit. What happened? So in the for loop for fit. When we send like a system.print line, it's not being printed. And I was using two different loops here. A regular for loop, and then we use a for each loop. And none of them are actually printing the print statements that I had. So let's use like a simple print and see if that works. No outputs. Okay. Okay, I want to do something here. I want to see why. Let me think. So my print statements are not printed. What happened in these other tests? Console output, empty error. Interesting. Okay. Give me 1 sec. I just noticed we just did a stupid mistake here. I did a stupid mistake. So we just have like here, we have map. When we just initialize map on line 11, so on line 11, we just initialize the map. So the size is actually 0. So it's not going to work. That's the reason why. So the mistake that I made here was it was not supposed to be map. It was supposed to be string. So that's what I wanted to do. So that was s that length. That's what I wanted to do. And since it's a variable of type string, we need to do s dot length and call that function. And yeah, that should solve the problem here. And from there, we could just print. What is it called again? Current char. That should do it. And let's see now the outputs. Good. Perfect. Now you see, now everything works. Now we passed every single test now without even needing to fix anything else. So the logic was great. So we just missed that little thing. One little mistake could actually make the whole program stop working. So that was the little issue that we encountered. So now let me remove it. Yeah, so now we're good to go. So let's just submit it, and so far I think it's a great solution. Let's run it. Great. Took us 40 minutes, almost. Too long. Okay, so continue. Got it. So I want to go back and take a look at what they said. So it says 15 minutes. So we should actually be able to solve this in 15 minutes. And I took 40. So almost like 3 times as much. So that's not good. We'll try to improve on it. So that was pretty much it. One thing that I wanted to do is look at other people's solution to the problem. And let's go to Java. Wow. Such a nice solution, just 10 lines. So he's using a char array. Okay. So s that char array. So it's basically splitting every single character in that string into a char array. So that's what he's doing. But when he's doing that s that to char array, that's a dope function that you need to remember that exists. Or you could look it up, but you need to be aware of its existence to, recall it and maybe like look it up. And one thing that it says is if s dot index of, he's using like the last index of. That's interesting. So if s, which is the string, that index of, s dot index of C at index I. So basically it's basically just finding that index here. It's finding the index, the first occurrence of that character in the string, and asking if it's equal to the last occurrence in that string. So yeah, that's a fantastic solution. So you're asking like, hey, if the first occurrence of that specific character is equal to also the last occurrence of that specific character, then return that specific character right away. And that's such a smart solution, because when you think about it, when you find like the first occurrence of something and also the last occurrence of something, and those two occurrences are actually the same, those two indexes are the same. If those two indexes are the same, that means that, it's essentially just like the same character, because the first occurrence and the last occurrence are actually located in the same index. So that means that there's no repetition. It only happened once. And that's why this solution is so clean and simple. I didn't think about that, but we can always improve, and it's actually good to see different solutions. And I love this solution. That's a great solution. All right, that's pretty much it for today. Thank you very much, and see you next time.